Alright, we're going to do the last two questions on this paper. If you are enjoying this series of videos, then please be sure to subscribe and show some support on this channel. It'd be much appreciated. The first one, the angle C of triangle ABC is 90 degrees, so we've got a right angle triangle here. AB is 5 inches. Okay, so first things first, we draw the triangle. Alright, nice. And we'll seize the 90-degree angle. And the triangle is ABC, so call this A, B, and we know B is 5 inches, okay? So the first part is we want to find the angle A. What's the angle A? Well, that's this. And we know that sine A is 0.4261, so all we have to do is at this angle A, they're calling it, is equal to the inverse sine of 0.4261, and that's equal to approximately 25.2 degrees. I have all the true values, saved, but and to use in further calculations, but for the purpose of writing it down, displaying it, we'll just use the one that we want to find the length of AC. Well, we now have this angle here, we have this side, and we're looking for this AC here. So relative to this angle, we have the hypotenuse and we have the adjacent. So we're going to look at cos. So we know that cos A is equal to the adjacent AC over the hypotenuse 5. So AC is equal to 5 equal to 4.52 inches, as far as we're concerned, really. Alright, we don't really need to know it to any other value. Now, the next part, just to create some room, I'm going to rub out this angle. It's not what I was going to do. And we want to put on a point D such that AD is 0.5 inches long. Well, and that's taken in AC, so it's on this line here. So we'll call this point D, and we know that this fits 0.5, and I won't put inches, we know we're dealing in inches, okay? And well, we know the length A6 is 4.52, so we know DC is 4.02. Okay, and I'll draw a little line across here to B, and we're looking for this angle here. So this is still a right angle triangle, fortunately, and we're looking for this angle that I'm going to call theta, and we want theta degrees. So now what information do we have? Well, we can find this bottom side CB by taking our original values AC and AB and using Pythagoras to get CB. And when we do that, we get we can use the tan formula to get tan theta to opposite over adjacent, so 4.02, and then the CB, if you do the Pythagoras, comes out as 0.1305, and this leads to theta equal to 62 degrees. And the reason I only actually used 4.02 in the calculation, I didn't go all the way to what it should be, because we only want to give the degrees to two significant figures. So if we're working 3 significant figures or higher, in the calculations that's accurate enough. So that's it for question 9. I'll have a quick pause, leave this, and I'll be back with question 10. Right, the final question for this paper is about 2 poles on a riverbank. So, a riverbank with parallel banks. Well, time for drawing some lines. Right, terrible job at that, but you know. We'll pretend these are parallel. Just gonna have to bear with me for now. And what's the problem here? The P and Q are a distance d apart, okay? So from an origin point O on the southern bank, the bearings of P and Q are respectively alpha and beta, so respectively, and beta is the bearing of Q, and importantly east of the north. So P and Q are this side of the north, right? Prove that if alpha is less than beta, then and the river is of width y, then d is equal to y multiplied by tan beta minus tan alpha. Okay, so remember, in your imagination these are parallel, but you know, they don't look too bad. So this here is y, and then, well, remember bearings are calculated from the north, and you would normally write them 3 figures, but whatever. We're going to have our alpha here, and then next up we're going to go out here and I have to extend this line. We're going to call this one beta, okay? And now we've got P and Q. That's part of the trouble with most of these problems, is just drawing a diagram, and then after that the solution becomes fairly obvious, especially if you can draw diagrams just any bit better than mine. But if we look here, if we extend this north up, we've got a right angle with the bank. So now we've got 2 right angle triangles, and those are one with O and P at some point that I'll call A, and the other one is, well, we'll draw it a little bit further out, it's O, Q, and this is still A here, so OA is Y in both cases, but here we have alpha, and here we have beta. Again, these are right angles, although you'd struggle to believe it. And we can work out the distance from A to P and from A to Q, and then the distance from P to Q, which is D, is just going to be the distance from A to Q, the distance from A to P. And with our rules of trigonometry for right angle triangles, well, tan alpha here is equal to opposite, so AP over Y. So AP is equal to Y tan alpha. This is already looking pretty good. And here AQ is equal to Y tan beta, and as I said before, b is equal to a cubed minus ap, and that's equal to y tan alpha, y tan beta, minus y tan alpha, that's equal to y tan beta minus tan alpha, and that's what we require. And the final part is evaluate y when OP and OP when d is equal to 85 yards. I'm going to take alpha equal to 32 degrees. I don't really know what this bit in the end means. Someone will have to correct me in the comments. I had a quick look at bearings, but I'm just working with this like, sort of an angle problem. And yeah, so alpha's 32 degrees and beta's 47 degrees from the north. Well, finding y is pretty easy. Y is just equal to the 85 yards over 47 minus tan 32, and that comes out at around 9.9 yards. And then to find OP, well, we'll just go back to these triangles here, and we've got y, and now we're trying to find the hypotenuse, and we've got this angle alpha, so that's the adjacent, and the hypotenuse, and then you rearrange that for what we want to find, OP, which is the hypotenuse, so we multiply it by that, divide by cos 32, that's equal to y over cos 32, and y is 189.9, and this comes out at 224 yards. Of course, I've been rounded for y and OP again, but remember, because this is 4 significant figures, writing that to 3 is still very accurate. Okay, that's it for this whole paper. Hopefully you found this interesting, see what questions were like. This level, I think, is situated at, it's the, the school exams, to see if you can get on the path to go into university. It's not a university exam, but it was made by the University of London from everything that I was reading, and so that's why I advertise it as such in the titles. But I don't think it's it's not university level of it. It seems more a bit of a mix between GCSE and A level. Like there's some law in here, but a lot of it's just basic trigonometry, triangle trigonometry, rearranging, solving equations. But yeah, if you do want to see more papers from perhaps different countries and different times in history and different specifications, then be sure to let me know below. Anything else you want to see, any tutorials, then be sure to tell me about that. But for now, hopefully you enjoyed. Please like, subscribe, and I hope to see you in the next one.